Okay, for today, it was super easy lesson, so we squeezed in an old chapter 4 quiz that the kids needed to finish grading and Dropboxing, and then we graded the lab before this, the Venn diagram lab. If you were absent today, you're going to want to talk to me about grading that Venn diagram lab, and you just may remind me and I'll grade it for you this time, but we grade it in the class as a group. And now it's 5.1 day 1, lines and slopes. And you're going to find that this is hugely review, but for a few kids, this will be critical because you may not remember how to find slopes and lines and different forms of line. All right, so what do you remember about linear equations? Well, I hope you know that. Do you know what linear even means? It means that it's a straight line. As opposed to nonlinear, which means what?
Not a straight line.
Not a straight line. This one, did I go exactly through the origin? Nope. So it's got a y-intercept and an x-intercept. And then how steep is the line? Well, that's the slope. All those make sense? So let's say I gave you a point on the line and another point on the line. Would you be able to write the equation for the line? It's something we practiced on the top 20, and so therefore today should be easy because we worked on that. Here's one. They gave us a couple points, 0, 0, and 2, 4. Take that first one, and would you write me the equation for the line that goes through those 2 points? If you're lost, start by finding the slope. Then there's 3 equations I'm going to write off to the side. y2 minus y1 over x2 minus x1. What's that one? Come on, what's that one? Slope. Y minus y1 equals m times x minus x1. That is just a rearrangement of the slope formula, but it's got its own special name. It's called point slope. Why? Because the point goes here and the slope goes here. That's called point slope. And last but not least, y equals mx plus b. And that's our 15-minute warning to the end of class. Today there was way too much stuff to possibly give you any work time today, so yeah, you might have 1 minute at the end, but okay. For this first slope, did you say 4 minus 0 over 2 minus 0, which would be 4 over 2, which is 2. Raise your hand if you had a 2 slope. Awesome. Now, if it was just the slope, that'd be fantastic, but it's not. It's find the line containing those points. So how many of you already knew to take one of the 2 points, and in fact, what's easier? 0, 0. And put it into this equation right here. That equation right there. So you'd go y minus 0 equals the slope times x minus 0. If you clean that up, it's just y equals 2x. And that turned into slope-intercept. Now that only is so clean and nice because we used the point 0, 0. If you used the other point, it would still solve to y equals 2x. It's one of the things people get surprised by. You can use either point, and it solves to the same exact thing. Okay. Just to be sure you got this, try problem 5. It should go quick if you know what you're doing. And do solve for y at the end. Pausing for a second. Okay, let's see if you did this right. -1 minus 3 over 2 minus 2. What the heck? Do you get what just happened? Yeah, and if you graph those 2 points, you'd be able to see it. Over 2 up 3 would be like that. Over 2 up -1 is like that. And oh my gosh, the line that goes through them would be like this. So the only question is it x equals 2 or is it y equals 2? This is the line x equals 2. Let's talk about its slope. How steep is that? Could you even make it any steeper? No. So that's infinite slope, but you don't say infinity. You say its slope is undefined. And you might be like, how can I write that as y equals something? You can't. It's x equals something. So no, you can't solve it for y. It's an x equals line. All right. What about a slope of 0? What if I had subtracted on the top and I'd gotten 0 on the top? Well, then your line goes like this. And how steep is that? If you were skiing on it, you wouldn't move. It's flat. Yes.
Yeah, slope of 0.
Slope of 0. So the slope equals 0 if they're flat. Slope's undefined if they're straight up and down. That's like a cliff. You're jumping off a cliff. You're not skiing. Okay. Well, the only other kinds of slope I want to talk about, this is positive slope, and then that red one, that has a negative slope. You can still ski down it, right? It's not undefined. It's just, it's going down as you read from left to right. So this one's got negative slope. This one's got positive slope. All right, good enough on that. So now, how can you make slope into something that's more pre-calcy? Well, here we have at 6 a.m., the temperature was 24. You see how they dropped that into a point? And at 10 a.m., it was 32. See how they dropped that into a point? Well, it's not that hard to do the slope here. It's 32 minus 24 over 10 minus 6, which would be 32 minus 24 is 8 over 6 over 4, which is 2. But now it has context. To what? To Sasquatch? To chickens? 2 in the morning? What the heck's the 2? Michael?
The 2 is a slope.
Yes,
And
but
that's going to be rate of degrees change per hour.
degrees per hour, because that's the units of the top divided by the units of the bottom. So the slope ends up being a rate of change. So in a real world problem, it's, yes,
Would we have to say if it's Fahrenheit or Celsius?
it'd always be good, but not something to worry about right now. Okay, so we're going to move on. I've talked about this form. I've talked about this form, but I didn't talk about this form very much. It's called standard form. And the way the kids get burned on it is this. They say, write this in standard form. And a kid gets it down and puts the X first, and then the Y, and then the number, and they're like, what? It is standard form. Anybody know what's wrong with it? Then you don't know that they have to be integers. Do you know what an integer means? I'll give you an example of integers. -2, -1, 0, 1, 2. Those are all integers. Would you have said those are whole numbers? Whole numbers is actually different. These are whole numbers. 0, 1, 2, 3, 4, 5. Whole numbers start with an O. Get it? Whole has an O in the middle, and a 0 is the first of the whole numbers. Okay, so whole numbers are there. You know what natural numbers are? You're learning something. These are actually important. These are wholes. Wholes start at 0. These are called naturals. That means you can't even use 0. What's the difference between wholes and naturals? A 0. That's it. Natural numbers are like 1, 2, 3. All of those other ones, notice, not the decimals in between. So it's like if you wanted to make a really simple definition, it'd be like whole numbers except they can also be negative. That's what integers are. It's like whole numbers, but they can also be negative. Because whole numbers can't be negative, actually. Why do you care? Well, it could be on the ACT test, and they might say, the following is an integer. If you don't know that that allows negatives, that'd be a problem. The following number must be a natural number. And you think the answer is -1. No, naturals can't be negative. Okay, so anyway, how can I get this to be a whole number? Or it also be a natural number. Yes. Yes, clear the fractions. One of the things I taught you on the top 20. You times everything by 3. And now you got 6x plus cancels 4y equals 21. Now it's in standard form. Okay, so standard form, these numbers have to be integers. But what if there was still a fraction? Well, figure out what the denominator is and times by that everywhere, and then there won't be a fraction anymore. Okay? One last thing. Can there be a fraction on the n number? Yes. These, I actually circled this and I shouldn't have. The last number, that can be a fraction. This and this have to be integers, which is kind of like positive and negative whole numbers. Okay. We've done this a couple times, so I don't think we need to do another one. But you'd start by finding the slope. And what equation would you use then, Gio?
To find the slope, you would do...
No. After we found the slope, which I'm assuming will be super easy, then what do we do?
After we find the slope, we do y equals slope plus y-intercept.
Do you remember this equation?
Oh, y minus y1, and then x minus x1.
You're missing something. You're really close, though. M, right there. Okay, so after you find the slope, you use this. Maybe I'm assuming you've got this down. Maybe you guys don't really. I don't know. I feel like you got it down. Just do this one and prove it. L, what'd you get for the slope? Okay.
I got 2/3.
All right. I agree. Cool. So 2/3 goes here. Cal, which point should I pick?
I picked 2, 1.
That was strategic. Why?
Doesn't have any negatives in it.
I agree 100%. Now, do you have to use those two? No. If you solved it for y, you get the same answer. But x is 2, y is 1. Y minus 1 equals 2/3 x minus 2. And if you multiply that all out and solve it for y, you've got slope-intercept. This one's called slope point or point slope. It's actually a perfectly good form. In fact, they tell us, the calculus teachers tell us they use this more than when they're solved for y. This is used more often because they actually usually need a point. Yes?
Oh wait, never mind.
Okay. It's easy to think I made a mistake, and maybe I did. Neil?
Isn't the slope negative 2/3?
Yeah, that's what I think.
Okay, double checking that. All right, so we have 1 minus 3 over 1. Oh, that's supposed to be a 1. Right there was a mistake. That's supposed to be a positive 1 minus... Nope, I'm wrong. Just got to erase this and start over. 1 minus 3 over 2 minus negative 1, which would be positive 3. To be honest on this one, I knew that the kid told me it was positive 2/3, and I thought, oh yeah, there must be a negative down there. So, sorry about that. It is negative 2/3. So this is a negative 2/3, and thank you. Okay, so yay. We've practiced finding something that you've known in the top 20 for a while. So that shouldn't be too tough. What else is there? There's context. If I said right now at 10:23, now that makes it more complicated because it's like hours and minutes together. At 10:23, the temperature outside is 45 degrees. That can be a point. See what I mean? And then you could have another point, which could be the time, let's say an hour from now. The nice part about that will be that when I subtract those two, 11:23. Let's say that the temperature grows to 50 degrees outside. You'd be able to go 50 minus 40 over that minus that is 1 hour. See how it cleaned up? And all of a sudden I got 10 degrees per hour. And it's not just a slope of 10. It is a slope of 10. That means a rate of change in the temperature outside. Okay, that's it. That's why today was easy enough to squeeze in the grading of the lab and the other stuff. So, all right, should you do some homework tonight? Yep. There's a few problems to practice. Should you also get your lab done and drop it in the Dropbox? Yes, but the Dropbox doesn't exist yet. It will probably over my lunchtime. I'll open up the Dropbox. Okay, so look for a chance to Dropbox the lab tonight. And that's all I've got for you for today.